Hello guys, my name is Jan. I'm one of the OpenMined contributors. In this video, I would love to encourage you to create reinforcement learning demos with OpenMined. So I'm sure you've heard about the recent AI breakthroughs where an AI agent is able to play Atari game or beat a world champion at Go. And really all these accomplishments have been made possible because of one specific machine learning area, which is reinforcement learning. And so the main idea behind reinforcement learning that it consists of learning best actions based on reward or punishment. So if we look at this graph, there are three main concepts. The first one is a state that describes the current situation. So it could be the positions of the different pieces on the Go board. You have the action, is what agent can do in each state. And you have the reward that describes feedback from the environment. So the AI agent is going to be able to learn by interacting through trials and errors, and over time is going to learn a sequence of actions that will lead to a long-term reward. So that's really the main idea behind reinforcement learning. If you want to continue to learn more about reinforcement learning, you can read this excellent blog post written by Andrzej Karpati. In this blog post, it gives you a good introduction to an algorithm named policy gradients, and he applies this algorithm on the ping pong game. So why do we want to apply reinforcement learning with OpenMined? So the first thing to keep in mind is that with OpenMined, currently the backend is implemented using Unity. And so they made these decisions because they want to make sure that data scientists have access to GPUs across a wide range of platforms like Xbox or mobile platform like iOS and Android. Also, as I mentioned earlier, AI agents are learning by interacting with environments, which is perfect because with Unity you can create any environment that you can imagine. For this reason, a couple months ago, the Unity research team, they released ML Agent SDK, and it's to help researchers and developers to train the AI agent within different environments using different techniques, like a deep reinforcement learning or evolutionary strategies. So I would like to emphasize a couple aspects of this environment. So you have three objects. So the first object is an agent. So for each agent, you can have a unique set of states and observations. They take unique actions within the environment and receive unique rewards for events within the environment. And an agent is controlled by a brain, and you have several brains. All the brains are contained within the environment. And this environment is most of the time called an academy, and you have different parameters, which is engine configuration, or you can also control the episode length, for example. So it's really a super flexible platform where you can have a single agent, or you can have several agents controlled by the same brain, or you can have several brains within the same learning environment. So this flexibility gives you the option to create different scenarios where you have a single agent or simultaneous single agent, adversarial self-play, cooperative multi-agent, and so on. And even you can increase the difficulty of the game over time by using the curriculum learning approach. So it makes it the perfect platform to do a reinforcement learning research. So let's talk about the benefits. So as mentioned, really OpenMined and Unity are fully integrated. So one of the benefits would be that a game developer, for example, could train a reinforcement learning agent on our game directly on our console instead of having to use a cloud service to access GPUs. So really, you could train your AI agent directly on your gaming console. Another benefit would be to train your reinforcement learning agent concurrently using several devices by using OpenMined Grid. And this approach could drastically speed up the agent's training. So that's couple ideas shared by the OpenMined community, but I'm sure once you start experimenting with the OpenMined and Unity, you're gonna find out new use cases. So here are a couple ideas how you can contribute to OpenMined. So the first approach would be to find an existing demo and replicate it using PyTorch or Keras interface. So if you look in the OpenMined repository, you have several examples. One is a carpool where we are using a PyTorch interface. Another one is a mountain car with the Keras interface. But really, you can look for a demo online. And for example, here we have a Medium post. It's a reinforcement learning with Keras plus OpenAI, and is implementing the DQN algorithm. And the DQN algorithm is trained on the mountain car environment. And so this environment is part of the gym library, which has been created by OpenAI. So it's not trained on Unity game. If we look at the code, so let's go down. So here is importing the gym library and also the Keras library. So if you want to replicate this demo and using OpenMined and the Keras interface, one thing you have to do is to add sift.interfaces in front of Keras, and it should work. So, I mean, the Keras interface and PyTorch interface are currently under development, and so it's very likely that some of the functions are not yet implemented in the interface. That's why I gave the link, so you can find where you can improve the library, the code. Also, it's possible that some functions haven't been programmed in the deep learning framework in the backend, OpenMined backend, and the PySift library. So if that's the case, you can add these new functionalities or new tensors. Also linked to also link the instructions. Another aspect that you might have to work on is to identify or fix any bottlenecks that could improve the current implementation. So I think by working on these demos, it's going to give you a very interesting experience by experimenting with different reinforcement learning algorithms like policy gradients or DQN. You can experiment with different environments from the gym library, and also at the same time improve the deep learning framework created by OpenMined. So it will be the first project. The second idea would be to create your own Unity environment and train your agent using PyTorch or Keras interface. So OpenMined has already created a proof of concept where OpenMined is a plugin into a separate Unity framework to train reinforcement learning agents. And so we have already two good examples where an AI agent learns to move to one direction. Another example where we have a pole that learned to remain upright. So let's look at the second example created by one of the OpenMined contributors. Let's play this game. So we can see that the ball keeps falling again and again, and the goal is to have the ball remains upright. So let's train an AI agent to do this. So here we have a Jupyter notebook where first we import the Sift library, but really you could implement the same demo using a Keras or PyTorch interface. And so first, so you import the Sift library, then you create the model, then create an agent, and then you deploy the agent to the Unity environment. And you can see, after a couple of seconds, the agent is already starting to learn by interacting with the environment through trials and errors, and at some point it's going to be able to have the pole that remains upright. So very quick demo to highlight how we can combine OpenMined and Unity on this simple example. And finally, one more idea would be to replicate Unity RL demos using PyTorch or Keras interface. If you look at a GitHub repository, Unity research team have shared a very cool demo where they have trained multiple independent agents to balance a ball on the platform. In the current implementation, they are using TensorFlow as a framework, but you could replace the TensorFlow implementation with the PyTorch interface. So if you're able to make this demo work with OpenMined, I think it would be an excellent example to showcase that we can do reinforcement learning research with OpenMined and Unity combined. So if you have more questions or if you want to share ideas, please feel free to reach out on Slack on openmind.slack.com. Thanks for listening and talk to you soon.